Give the next heading, guys. Strength. Everyone, give the next point. Strength. Give the next heading. Everyone, strength. Now, what is meant by strength, guys? It is defined as maximum value of stress. Listen my words carefully. It is defined as maximum, what everyone? Maximum value of stress which material can sustain. Which material can sustain without failure. Means it is highest value of stress. Means if you go above that stress, what is going to happen?
Break.
We don't say break, guys. For us, failure means doesn't mean a break. Break means is like a tsunami scenario. Means there is like a, there will be a tsunami. There means a worst thing is going to happen if there is a breaking. Failure means permanent deformation. Guys, see, what is the meaning of word failure? See, failure means doesn't mean break. For us, failure means permanent deformation. Why permanent deformation we will consider? See, what I told you, guys. What I told you in the previous session. What I told you. In strength of material, everything must be what? Within elastic limit. Why within elastic limit? Suppose there are two gears. There are what, guys? Two gears are there. Means two gears are attached to each other, guys. Suppose this is a one gear. And to this gear, there is another gear attached to this one. Everyone. So, if there is a permanent deformation of the one gear, then what is going to happen? It is not going to have run properly, this gear arrangement. Suppose there is a one shaft is there, guys. And on that shaft, there is another shaft is connected through this key, guys. Suppose there is a key. 1 minute, I am going to take one example so that you will get a more idea. 1 minute, I will take one example. Suppose this is what a shaft, guys. This is one shaft. This shaft is connected to what, guys? This hollow shaft, everyone. So, if there is a permanent deformation in this pin, is there any proper connection between these two things, guys? No proper connection. So, for us, failure means permanent deformation. What is the meaning of word failure? Failure means, see, if you say breaking means what? A tsunami-like scenario, earthquake-like scenario. There, no one can survive. Means entire assembly will become useless if there is a breaking. But for us, failure means what? We never go up to that point. For us, failure means what? Permanent deformation. And why we are keeping failure means permanent deformation, guys? Why we are keeping failure means permanent deformation? Because after that one, guys, what is going to happen? The connected links will not work properly. If the failure of means, if the permanent deformation of the one gear going to take place, then what is going to happen? Another gear will not merge properly, engage properly with that permanent deformed gear. So everyone got is the meaning of failure? Failure means what? Permanent deformation. Failure means what, everyone? What is the meaning of failure? Failure means permanent deformation. And now tell me, guys, at what point permanent deformation is going to take place? After the elastic limit? Permanent deformation is going to take place. What, guys, everyone?
After the elastic limit.
So, 1 minute. So, permanent deformation is going to take place. What, everyone? After what? Permanent deformation is going to take place. Takes place after what, everyone? After elastic limit. So it means what? See, guys, try to see the linking. See, I am going to read the first sentence again. What is meant by strength? Strength means what? Maximum value of stress you can sustain without failure. Failure means permanent deformation. So permanent deformation is going to take place at what? elastic limit. So in other words, whatever the value of stress at elastic limit, can we say it as a strength? Can we say, guys? Listen my words carefully. So therefore, in other words, because after elastic limit, what is going to happen? Permanent deformation, failure is going to happen. So in other words, the value of stress. So in other words, strength is the what, guys? Everyone, strength is the value of stress at what, guys? Everyone, at what? Elastic limit. So therefore, in other words, strength is the what? Value of stress at elastic limit. Because see, what is the meaning of strength? We have seen maximum value of stress, after which material can failure. So means what? When failure is going to take place? After the elastic limit. So in other words, whatever the value of stress
At the
elastic limit, we will say it as a strength. Oh, that is the strength of that object. After that means, suppose my strength is what? Teaching up to 10 hours. I can teach up to 10 hours. That is my strength. Means up to that point, I am going to teach. But after 10 hours, what is going to happen? I am going to fail. Okay. There will be body pain happens in my body if I am going to teach more than 10. So that is what a strength for me. Everyone got it? So meaning of strength. Please everyone write down this discussion. So this is all about strength, guys. See, whatever the definition of strength we have seen, we need this definition in other chapters also, guys. So this chapter is very, very important for us for the remaining chapters. So this is all about strength, everyone. Now give the next heading, factor of safety. Guys, give the next heading, factor of safety. It is denoted by what, guys? Everyone, FOS. Or we will say it as what? Factor of safety. Another name is what? Safety coefficient. Everyone, factor of safety. Or what, guys? Everyone? Or safety coefficient. See, guys, everyone try to understand the scenario. What is meant by factor of safety or FOS? See. FOS is equal to, now guys, don't write anything. Let me first of all complete the things and then I will give you a proper time. So FOS is equal to what? A strength. FOS is equal to what? A strength divided by what? Maximum permissible stress. Everyone try to see the scenario. What is meant by factor of safety? Factor strength divided by
maximum permissible
stress. Permissible, guys, everyone try to see the scenario. Maximum permissible stress. Now guys, what is the meaning of this one? I will explain you. See, I will give you one example of two-wheeler, guys. Suppose I am going to take an example of two-wheeler. Now tell me, maximum how many number of people can sit, guys? Maximum. So strength of the two-wheeler is what? 4 number of people. Strength means in critical situation of 4 people, 4 person can sit on the two-wheeler. But how much allowed by the government? Allowed is how much? Maximum permissible or allowed? So how many allowed, guys, or permissible? Only 2 persons are allowed. So then factor of safety of two-wheeler will become what? Everyone? 4 by 2. So it will become what? Factor of safety 2. And why we are keeping that safety factor, guys? Safety factor. So that if there is a situation like a sudden failure situation. If there is a situation like a sudden failure. If you remember our discussion from the previous things, types of loading, guys. Everyone. If there is a situation like a sudden failure. Guys, see. If there is a suddenly applied load of 50 Newton is coming on the object suddenly. So there should be some gap must be there. Oh, object must sustain that load also. So that's why we always keep load within a means below the strength, guys. We will not never keep the always. We will not go up to directly strength point. Everyone, listen my words carefully. We will not go directly to the strength point, guys. We will go up to what? Up to some level. Means what? I'm going to take up an example for this one. 1 minute. So always, guys, so I'm going to take one example. From that example, we will get an idea. Suppose one object is there whose strength is what? 200 meganewton per meter square. How much strength is, guys, what? 200 meganewton per meter square. But maximum permissible is what? We will allow only up to 50 meganewton. Because whenever there is accidental situation come, suddenly, so what? Maximum permissible stress we will allow up to, suppose what? 50 meganewton per meter square. Then what will be the factor of safety, guys, for this scenario? Everyone?
Strength divided by
Strength.
maximum plus permissible
Strength. Maximum strength divided by what? Everyone? Maximum
permissible stress.
Maximum permissible stress. 200 divided by what, everyone?
50.
200 divided by 50. So what will be the value of FOS, everyone?
4.
Value of FOS will be what, guys, everyone? 4. Guys, getting my point? So you got the meaning of? So why we are keeping that 150 Newton extra? So that there should be object should sustain that suddenly applied load scenario, impact load scenario. There may be any scenario, accidental damage, like that things will come. So we will keep always load within a strength, below the strength, guys. We will never go up to strength point, guys. We will know, we always keep our object below the strength level. Too much below the strength level. Generally 2 to 3 factor of safety we always keep. Minimum 2 always we will keep. So please everyone, write down this discussion of the factor of safety. Everyone got the meaning of factor of safety, guys? Anyone have any doubt in this factor of safety? Try to see the things, guys. Very, very important discussion we are doing, everyone. Now try to see the next point, everyone. Give the next heading. Change in length. How we denote, guys, change in length? Can anyone suggest me how we denoted change in length earlier? Delta L. So we denoted change in length by what, guys? Everyone? Delta L. Now, everyone, by Hooke's law, what we have seen? Everyone, now listen my words carefully. Just give the heading. Now don't write anything after writing down the heading. So by Hooke's law, what is the relation of Hooke's law we have seen, guys? Can anyone suggest me? Can anyone tell me? What is the relation of Hooke's law?
Stress is proportional to the strain.
Stress is proportional to strain up to elastic limit. And then, if you want to remove that proportionality symbol, sigma will be equal to Young's modulus into what?
Strain.
Strain. Small e, guys. Now, everyone try to see the scenario here. So, sigma is equal to what? Capital E. What is the relation of small e? We have seen, guys. Can anyone tell me? What is the relation of small e? Tell me, guys.
Delta L upon length. Extended length upon length.
Change in length upon L. We have seen relation of E will be equal to what we have seen? Change in length divided by original length. So if you observe the things here carefully, everyone, if you observe the things carefully, so delta L will become what, everyone? What is the relation of delta L? Then we can write down sigma into L E. Guys, see this one, divided by what? Capital E. What is the meaning of capital E, guys? Everyone? What is the Young's modulus or modulus of elasticity?
Modulus of elasticity.
So in this way, we will get a what? Relation of change in length, and relation of change in length will be what? Sigma L by E. Sigma L by E, capital E. Now can you tell me what will be the unit of delta L, guys? Everyone? Change in length unit will be what? Meter. So change
Meter.
in length in unit will be in what? Meter. So now we will say this is what our equation number 1, guys, everyone. We will say it as what? Equation number 1. Now above equation 1, above equation 1 is valid for any type of loading. Is valid for what? Any loading. Means this equation. This equation, guys, valid for what? This equation of, now any type of, what is the meaning of what? Any type of loading? We have seen 3 type of loading, guys. What we have seen in our discussion? We static load or gradually applied. Then second type of load is what? Suddenly applied. And third type of load is what? Impact load. So for any type of load, this relation of change in length, guys, everyone, this relation of change in length is applicable for what? Any type of loading, whether it is a static load or gradually applied load, whether it is load, suddenly applied load or impact load. So for any type of loading, this relation of change in length is applicable. Please everyone write down this discussion of delta L, guys. Write down properly, guys, everyone. And guys, one important instruction, whenever I am writing any point, just leave one or two line and then start writing down the next heading, guys, so that your notes will become a proper systematic format. Please everyone write down the discussion. So this is all about, guys, so this is what a relation of change in length for any type of loading. Now we have seen, guys, observe the things here carefully. For static load, what is the relation of stress we have seen for static load, guys, everyone? What is the relation of stress we have seen for static load? Sigma is equal to what we have seen, guys, can you tell me? We have seen in the morning only. Not force into area. Force divided by area. What is the relation of sigma we have seen for static load? F by A we have seen. And we will say this is what our equation number 2. What we will say? This is what our equation number 2. Now what we are going to do? We are going to substitute. What we are going to do? We are going to substitute equation 2. What we are going to do? Substitute equation 2 in what, guys, everyone?
Equation 1.
In equation 1. Substitute equation 2 in equation 1. So then what will become, guys, everyone? So equation 1 will become, 1 minute. Equation 1 will become what, guys? Delta L is equal to, instead of sigma, what we will write down? F by A into L divided by what? E. So if you arrange properly, guys, what it will become? Delta L will be equal to what? F into L by AE. So this is what another relation of change in length. But guys, condition for applying this relation is what? We will say this is what our equation number 3. Now what will be the unit of, guys, what? This delta L, what will be the unit of delta L here? Tell me everyone.
Meter.
Change in length, unit of change in length will be in what?
Meter.
In meter. So here delta L must be in what? Meter. Now there is a one condition for this one, guys. So this relation of change in length, FL by AE, where FL by AE, or we will say, instead of here, above relation, above equation 3 is only applicable, above equation 3 is only applicable for what, guys, everyone?
Static load.
Static load. Why? While deriving this relation, we have replaced this sigma by what? F by stress due to static load. So means what? We have replaced sigma by what? F by A. So that's why this relation of change in length is only applicable for what, guys? Static load. Another name for static load is what, guys? What is another name for static load, everyone?
Gradually
Gradually load. Very good. Another name for static load is what, guys? Gradually
applied.
applied load. Guys, discuss with me. It is beneficial for you. Please everyone start writing down this discussion. Everyone completed up to this point? Now try to see the things here carefully, what we have to do and how we are going to approach the things further. Now we will see what is the meaning of tension and what is the meaning of compression, guys. Everyone, we will see with the help of this note. Everyone observe the things here carefully. Suppose we have one prismatic bar. Guys, what we have? Everyone, we have what?
One prismatic bar.
Prismatic bar. Everyone, try to see the things here carefully. We have what? A prismatic bar. Prismatic bar means what? Same cross-sectional area throughout the length. So this is what we have, what? A prismatic bar. And here we are applying a force, what? A force of outward, guys. Everyone, what we are going to do? We are applying a force of outward in this way and this way. So now tell me, this is the tension scenario or compression scenario, guys. Everyone, this scenario is of what? Tension scenario.
Tension scenario.
Tension scenario. So this scenario of F is what, guys? Everyone. So this scenario is of what? Tension scenario. And here the type of stress it is going to develop is what? A tensile stress. Tensile stress. Which type of stress is going to develop?
Tensile.
Tensile stress. Now another scenario will be what, guys? I am going to copy the same drawing or I will draw once again. So there is a what? Everyone.
Compression.
So there is a what? A same object we are going to take. Same prismatic bar we are going to take. And in that case, second scenario, what we are going to do? We are going to apply a F. Force F inward. See this one. What we are going to do? We are going to do what? A force F inward. So in that case, what is going to happen?
Compression.
So it will be what, guys? Everyone. So what is going to happen? This scenario is of what? Compression. So in this case, we will get a what? A tensile stress. What we will get? In this case, we will get a tensile stress. In this case, what we will get? Everyone?
Compression.
Compressive stress. Everyone getting my point? Try to understand the scenario, guys. Try to understand meaning of each and every word. So tensile stress or what, guys? Everyone? Compressive stress. So please everyone write down this note. Write down properly. Guys, always leave the one line and then start write down the next point. Everyone. Don't draw the drawing by freehand, guys. Use a proper pencil scale. Use different color pen. Everyone completed, guys, up to this one. So this is what our tensile stress scenario means, tension scenario and compression scenario. The next, give the next heading. Strain energy. Guys, give the next heading. Strain energy. Now, what is the meaning of strain energy, guys? Strain energy means what? Energy or work done required for the straining. See, whenever there will be a straining is not going to take place automatically. We have to do some work done. So, strain energy is nothing but what? So, energy stored, work done. See, guys, what is meant by strain energy? Strain energy is nothing but what? Work done to do the straining, guys. What is meant by straining? Straining means what? Work done to do the what? To the straining, guys. Everyone try to see the scenario. So work done. Strain energy is the energy stored. Strain energy is the energy stored in the object. Stored in the object due to what? Straining. Now what is the meaning of straining? Straining means what? Change in length. What is the meaning of straining, guys? Everyone?
Change in
Straining means what?
deformation, change in length.
Straining means change in length. So whenever, strain energy stored in the object due to straining. So straining means change in length. So whenever there is a change in length of the object, what is going to happen? There will be energy stored in the object. And what that energy stored? So that is whatever the work we are doing for this straining, that will be going to store there. So strain energy is what? Work done due to work done for this straining. So what is 1 minute, guys? There is a one important term in your exam question. Work done in straining the assembly. See this one, guys. So there is a one question. Work done in straining the assembly. So whatever work done we are going to do straining the assembly, that work done is nothing but what? So what is the meaning of this word, guys? In this question they are asking us what? Strain energy. What they are asking us in this exam question? They are asking us work done. So in other words, we can say what? What we can say, guys, in other words? Strain energy is what? Work done in straining. What is meant by strain energy, guys? Means what? Work done in straining. And what is the meaning of word straining? Straining stand for what? Change in length. Whether it is an extension, this is the extension scenario. This is what? A compression scenario. So work done in straining. And so please everyone, before going further, please write down this discussion. See, understanding the strain energy is very, very important for us, guys. Because our upcoming discussion is totally depends on a strain energy. So that is what, guys, everyone, that is all about. So now, what is the relation for strain energy, guys? Everyone, try to see the scenario. For any type of load, guys, everyone, we will not go into the derivation. For any type of load means what? Static load, suddenly applied load, and impact load. For any type of load, strain energy will be equal to what? Strain energy will be equal to what? Sigma square by 2E into what? Volume. What will be the unit of energy, guys? Can you tell me, everyone? What will be the unit? SI unit will become what? Guys, we have written in the beginning of this chapter. What will be the SI unit, guys? Everyone, unit of energy. Can anyone tell me? Unit of energy, we have seen. What is the unit of energy, guys?
Kilojoules.
Not kilojoule. Only joule. SI unit. I am asking you SI unit, guys. So, unit of energy will be in what? Joule. Capital J. So, this is what our strain energy. 1 minute, guys. So, for any type of load, strain energy will be equal to what? What will be the relation? Sigma square by 2E into volume. I will explain what will be the relation of volume. After that, I will give you one note. But for static load, guys, everyone, for static load, another name for static load is what? Gradually applied load. Very good, guys, everyone. Static load or what? Gradually applied load. And relation of static load or gradually applied load will be equal to what? Relation of strain energy. Half into F into what, guys? Delta L. And what will be unit of strain energy? Tell me, everyone. What is the unit of SI unit of strain energy, guys? Everyone? Joule, guys. Capital J. J stand for what? Joule. So please everyone write down these two relations of strain energy. One is for static load, another one is for any type of load. Please, guys, everyone. So this is all about strain energy, guys, everyone. Now try to see the scenario here. For everyone, completed up to this point. Now give the next point. Next note, guys, everyone. What next note you have to give? First one. For prismatic bar, guys, everyone, listen words carefully. For what? For prismatic bar. What is the meaning of prismatic bar, guys, everyone? Same
cross-sectional area.
Yeah, throughout the length. So for prismatic bar, volume is equal to what? Area into length. What is the for prismatic bar? Prismatic bar is what? Area into length. And unit of volume is what? SI unit is what? Meter cube. So SI unit of volume is what? Meter cube. And what is the meaning of A, guys? A stand for what?
Area.
Cross, not only area. We will say cross-sectional area. So A stand for what, guys? Everyone, here meaning of A will be what? Cross-sectional area. And this cross-sectional area, what will be the unit of area, guys? We have seen SI unit in what? Meter square. Huh? Please everyone, remember the point. All the things in mechanics we need a SI unit. It is not, see, the speciality beauty of mechanics is what? Here everything is in SI unit. Everywhere we will generally prefer SI unit only. And what is the SI unit? Standard units. Means what? For energy, SI unit is what? Joule, not a kilojoule. For mass, SI unit is what? Kilogram. Okay. So I have given you a SI unit of in the beginning of this chapter, guys. What I have given you? Different things, different quantities, SI unit. I have explained you. Angle, pressure, area, all these things. So you should be familiar with all these terms. So before going further, please everyone write down this note of prismatic bar volume.
Sir, for this static, you told the strain energy half F into delta L. So the other one is any type of loading. So any type of loading, sir. So basically for suddenly applied load and impact load will be used that, no?
We will use that one for static load also, sir. So this relation of strain energy, see, this relation of strain energy is applicable for static load also, suddenly applied load also, and impact load also, sir. For any type of load.
Okay.
It is not necessary. But this compulsory only for what?
For static load only.
Only static load. Okay, sir? You are getting my point?
Okay.
So for the static load also the top one we can use.
Yes, for
so
static
will
load.
be same.
Yes. For static load, we can use this relation also or this relation also.
Answer will be same.
But suddenly applied load or impact load, we will use this top one only. This one. Now give the next heading. Everyone. Give the next heading, compound bar. Everyone, give the next heading, compound bar. There are two types of compound bar. One is a what? Series bar scenario. And another scenario is what, guys? Parallel bar scenario. So we have what? Two compound bars are there. One is what? Series bar scenario. And another one is what? Parallel bar scenario. Please everyone write down this discussion. Series bar and second one is what? Parallel bar. Now try to see the scenario here, guys, everyone. So first type of compound bar is what? Series bar. First type of compound bar is what? Series bar. Everyone try to see the things, guys. I am going to draw one drawing. From that drawing, you will get a more detailed idea. And whatever the things we have studied till now, we are going to apply all that things to the series bar scenario, guys. Now, what is meant by series bar scenario? We have what? Up to this point, one cross-sectional area, guys. Everyone. Everyone. Up to this point, guys. Everyone, what we have? We have what? One cross-sectional area up to this point. Then, from here to here, what we have, guys? Everyone. From this point, everyone, we have seen
smaller cross section area.
A smaller cross section area. So this is what a one part. This is what another part. Then we will have a third part. So first part, second part, and we will have a third part, guys. Everyone observe the scenario. See the things here carefully. So here we have a series bar and we are going to see, here we have shown 3 parts. It is not necessary that only 3 parts will be there. There may be 2 parts also, there may be 4 parts also, any number of parts. But remember, part 1 attached to the part 2, part 2 attached to the part 3. So this, in this case, so this is the series scenario. So this is what our part 1, this is what our part 2, this is what our part 3. Part 1 area is what? Cross-sectional area A1, modulus of elasticity E1. Part 2 modulus cross-sectional area A2, modulus of elasticity E2. For part 3 cross-sectional area A3, modulus of elasticity E3. And here on this prismatic bar, what is going to happen? We are going to apply what, guys? Everyone remember one point. What is the speciality of this series bar? For all the parts, that center line must be same, guys. Same center line of part 1, part 2, part 3. Means if you draw one single line from the middle, exactly from the center, same. It must be same for everywhere, guys. Observe this one. It is same. So this is same for part 1, part 3. See this, observe this line. And generally how we will draw, try to draw proper center line? Instead of dotted. 1 minute, guys. How we will generally prefer center line? Bigger line, smaller line. Bigger line, smaller line, bigger line, smaller line, bigger line, smaller line. In naval also you have seen center line word. If you studied the navals, bigger line, smaller line. So in this way, guys, you are getting my point. Try to understand the scenario here. So if you observe the things here carefully, so what does you come to know that, guys? Everyone, what does you come to know that? Everyone observe the things. So here applying a load, axial load. Here I am showing you tensile load. Doesn't necessary that it is always a tensile. It may be a compressive also. So here I am showing you tensile. In case of tensile load, there will be extension. If there is a compressive load, then there will be what? Compression scenario. So here we are applying a yup. Now here we have a 3 part, part 1, part 2 and part 3. I am going to show the length of each part. So here from this point I am going to draw one dotted line. 1 minute, guys, just have some little patience. From here also one dotted line. And from here also, guys, I will show that one dotted, don't worry. I have another magic here. So a dotted line. So now try to see the things here carefully. So what I am going to do, I am going to draw, make it as a what? A dotted. Here also a dotted. Here also a dotted. So now what will be the length of part 1, guys? Everyone, from here, what will be the length? Everyone, L1. What is the length will be what, guys? Everyone, L1. Then from here to here, what will be the length, guys? L2. So this length will be what? Everyone, length
L2.
will be what? L2. And then what is going to happen? From here to here, what will be the length?
L3.
What will be the length, guys? Everyone?
L3.
L3. So here we have a length L1, L2, L3, guys. You are getting my point? So this is what our series bar scenario, guys. Please everyone, before going further, give the heading series bar and draw this figure properly. It is, guys, 1 minute. Before drawing the figure, here I am showing you 3 parts of the series bar. And what is the speciality of series bar? For all parts, center line is the same. And here load F we are applying axially. See, here just I am showing you tensile load, but it is not necessary that we have to show tensile load. The load may be a compressive also. And what is meant by tensile and compressive load? We have already studied. This is the tensile load scenario. This is what? A compressive load scenario. Everyone. Now write down the discussion from the screen. Okay, everyone completed? So now whenever we have a series bar scenario, guys, everyone, whenever we have a series bar scenario, whatever the force F, we have external force F, same force will be in part 1, Same force will be in part 2 and same force will be in what? Part 3. So force in each part. Force in part 1, force in part 2 and force in part 3 guys. Here see this one. Here force in part 1, force in part 2 and force in part 3. So same force will be in each part. So whenever we have a series bar scenario, so same force will be there. Now stress. Now tell me guys, my question for everyone. Is it a stress in same in each and every part or it is a different guys?
Difference.
Why different guys? Why stress is different?
Area difference.
Because stress is a force upon area, so all three roads have different
area.
cross-section.
So different cross-sectional area. So that's why stress in each part will be different. See guys, because though force is same, but cross-sectional area of each and every part is what? A different. So that's why stress is what guys? A different one. Everyone observe the things here carefully. So sigma is equal to what? Everyone? Force stress in part 1 will be equal to what? F1 by A1. F is same everyone. So we will say F. Stress in part 2 what we can say? Sigma 2
F by
A2. And similarly stress in part 3 will be what guys? Everyone? F by A3 guys. And see, this is the whatever things we studied till now, we are going to apply the scenario to the series bar situation and to the what guys? To the parallel bar situation. Please everyone write down discussion about stress. Sigma 1, sigma 2 and sigma 3. Everyone. So guys, everyone got the meaning of sigma? Now we will see change in length. So change in length of the part 1 guys, everyone. Change in length of the part 1 for any type of load. Relation of change in length guys, can anyone suggest me? What is the relation of change in length? What we have seen for any type of load? See your previous discussion guys. For any type of load, relation of change in length guys we have seen somewhere. Tell me. Go through your notes guys, everyone. For any type of load. For any type of load, relation of change in length is what?
Sigma square
Sigma square, not
divided by 2E
no.
into volume.
Guys, this is the relation for the strain energy, na guys?
Sir, sigma into length upon E.
Sigma into L. So stress change in length of the part 1 will become what? Sigma 1 length of part 1 by what guys? Everyone?
Yes.
E1. Got it guys? Everyone? For any type of load, what is the relation of change in length guys? Everyone? For any type of load, relation of change in length is what? Everyone? For any type of load, what is the relation of change in length? Sigma L by E for any type of load. Guys, we have seen. So sigma 1 L1 by E1. So for part 1 change in length. Or another relation. Now tell me, this F is which type of load here guys? Tell me. This F is which type of load? Static.
Tensile
load.
Tensile. Okay, tensile load. But in tensile, it is a static, suddenly or impact?
So static load.
Static. How does you come to know that it is a static load? How does you come to know that?
Because constant force is applied, sir. It is not suddenly applying to this
See,
body.
means they have not mentioned anything about the load. They have not mentioned. There is no any falling mass is not there. There is no impacts. There is no suddenly applied. Means just they have shown only force F. It means what? What we have studied, guys. If you remember our discussion, what we have studied by default, guys. If you remember our discussion, default type. Default. Only what? A static load. So here, whenever we have a series bar situation, the default type of load is what, guys? Everyone, whenever we have a series bar situation, default type of load is what? Static load. So, and for static load, another relation of change in length is what, guys? Tell me. For static load, what is the relation of change in length? Another relation. F
by E.
That is the relation. F by A is what? Relation of stress.
Only stress.
Only F by A. Relation of change in length for static load, guys.
F into L divided by A into E.
Correct.
FL by
A.
Correct. Very good, guys. So what we will say? F into F is the same everywhere. So we will write down F L1 divided by what, guys? Everyone?
Area into
A1
A1
into E1. Stress change in length in must be what? Meter. So here we got it, change in length of the part 1. Similarly, we will get a what? Change in length of what? Part 2. What will be the change in length of part 2, guys? Everyone? Sigma 2
into L2
L2 divided by what, guys? Everyone?
E2
E2. Equal to what, guys?
F into L2
F into L2 divided by what? Everyone?
A2 into E2
A2 into what? E2 in what? Meter. Now, guys, everyone, the next thing is what? Change in length of what, guys? Part 3. Sigma 3 into L3 divided by E3 is equal to what? F into
L3
3 divided by
A3 into
A3 into E3. It must be in what, guys? Everyone? In meter. Any doubt in this discussion, guys? Everyone getting my point? So before going further, please everyone write down this discussion of change in length of the part 1, part 2 and part 3, guys. Guys, don't write down blindly. Try to understand meaning of each and every sentence. Ask me doubt, guys. If you have any single doubt also, silly doubt also, ask me that doubt. So guys, now, delta L1, delta L2 and what, guys? Everyone? Delta L3. So we have seen change in length of part 1, change in length of part 2 and change in length of part 3. Now guys, the next thing will be what? Total change in length, delta L total. Delta L total will be equal to what? Change in length of part 1 plus what, guys? Change in length of part 2 plus what, guys? Everyone?
Delta L3
Delta L3. Delta L1 plus delta L2 plus what, guys? Everyone? Delta L3. So here we will get a what? Total change in length. Please everyone write down the discussion of total change in length. Now guys, we will see a total strain energy, guys. Here, strain energy total. Everyone observe the relation here. Strain energy total. So strain energy total will be equal to what? So this is what a series bar scenario, everyone. This is what guys, everyone? Series bar scenario. So here we have what? Strain energy of part 1 plus what, guys, everyone? So our strain energy total will be consist of what? Strain energy of part 1 plus what, guys, everyone? Strain energy of what? Part 2 plus what, guys, everyone? Strain energy of what? Part 3. So strain energy of part 1 will be equal to what? We have seen strain energy. For static load, we have seen the relation of strain energy is what? Half into F into delta L. So change in length of what? Part 1. Strain energy of part 2, what we have seen? Half into F into delta L2 plus half. Strain energy of part 3 will be half F into what, guys, everyone? Delta L3. What are the things we can take out common, guys, everyone? Half into F. So it will consist of what? Delta L1 plus delta L2 plus what, guys, everyone? Delta L3. So what? And we have seen just now. See this one, guys. Just now we have seen. Observe the things here carefully. What we have seen? Delta L1 plus delta L2 plus what, guys? L3. So it consists of what? So half into F into what, guys, everyone? L total. So in this way we will get a what? Strain energy in the case of what? Series bar scenario. And what will be the unit of strain energy, guys? Tell me, everyone. Joule. What will be the unit of strain energy, everyone? Unit of strain energy is what? It must be in what? So whenever we want to find out total strain energy in case of the series bar scenario, what will be the relation? Half into F into what, guys, everyone? Delta L total. Guys, completed everyone up to this point?
Completed, sir.
Now the next scenario is what, guys? Everyone, give the second type of heading is what? Give the next heading. Everyone, after leave the 1 or 2 line. Everyone, leave the 1 or 2 line and give the second heading. Parallel bar, guys. Everyone, give the heading. Next heading. Now, what is the parallel bar scenario, guys? Everyone, observe the things here carefully. In the case of parallel bar, guys, if you observe this one, this is what up to this point. There is a 1 bar scenario, everyone. Up to this point, we have what? A 1 bar. And to this one, suppose this is what? Part 1. Everyone, this is what? Our part 1. So this part 1 is attached to what, guys? This is the blue one is what? Part 1. And this part 1 is perfectly attached. This part 1 is perfectly attached to what, guys? Everyone? Part 2. So we have what? A part 1. A part 1 is what, guys? Everyone? Perfectly attached to what, guys? Everyone? Part 2. So this is what? A black one is what? A part 2. So part 1 and we have what, guys? A part 2. And here we are applying some load, axial load F. What we are doing? We are applying a load F. Observe the things carefully. On this side F and another side also F we have. So whenever we have such type of scenario, guys, so this is what our axial load scenario. So here we will have a F and here we will have a F, guys. Before going further, please everyone, draw this figure properly. So here we have a 2 part, part 1 and part 2. See the load, how we are applying the load. And remember one point, guys, part 1 and part 2, they are rigidly attached each other. Means if they, see, they are rigidly attached each other. If they want to move, means if you are applying force up, if you are, both will start move together, guys. That is meant by parallel bar scenario. Means part 1 and part 2 both will start move together. Please everyone, draw this figure properly. Guys, completed the drawing. Now try to see the scenario. Whenever we have a parallel bar scenario, guys, in any chapter, we will have a parallel bar scenario in case of the thermal stresses, in case of a torsion in compound shaft, in case of a torsion in stream. There are different chapters are there. So in any scenario, we will have a parallel bar scenario. There are 2 things are there. One is the equilibrium situation, another one is a compatibility. Now what is meant by equilibrium? First of all, we will see. For equilibrium, guys, everyone, observe the things here carefully. For what? For equilibrium. Equilibrium means what? Relation between forces. What is meant by equilibrium, guys? Equilibrium means what? Relation between forces. So force in part 1. So where that force F will go? F will go in what? Force in part 1 plus what, guys? Force in part 2 will be equal to what? Our total force. Yeah. Now we have seen, guys, if you remember our discussion, we have seen what? Stress is equal to what? F by A. So stress in part 1 is equal to what? Force in part 1 divided by area of part 1. So F1 we will write down what, guys? Everyone? Sigma 1 A1. Sigma 1 into what, guys? Everyone? A1. So can we replace F1 by what? Sigma 1 into A1. Can we do that, guys? Everyone? Can we write down F1 by what? Sigma 1 A1. Can we do?
Yes.
And then what? F2 by what? Everyone?
Sigma 2 into A2.
A2. And that will be equal to what? Our external force F. Anyone have any doubt in this equilibrium scenario, guys?
Sir, this equilibrium scenario, can you explain once again?
Yes, sir. No problem. See, guys, 1 minute. 1 minute. Don't write anything. Let me first of all explain once again. See, what is meant by equilibrium? Equilibrium means what? State of balance. So, whatever the force we are applying, external force, where it will go? Where it will go, guys? It will go from this end. It is going to transfer to the other end. But how it is going to transfer? So, through the material. Means some force will transfer through the part 1 and some part will transfer through the what, guys? Everyone? Part 2. Means what? Whatever the force, yup, where it will goes? Some part will go into the part 1. Some part goes into the what? Part 2. Everyone getting my point?
Sir, this F1 and F2, yes, some part is going on F1 and some parts is going on the bar 2. But this, both bars are moving together right now, sir.
Both? No, sir, not no, sir. This side we have applied F and this side we have applied F, sir.
Okay, sir. So, in the tensile stress, this both bar will be fused together.
Means, see, that is what I told you in the beginning. Part 1 and part 2, they are perfectly attached each other, sir. Means whenever we apply force F, they will start move together. Their extension will be together, sir. Whatever the extension of part 1, same will be the extension of part 2. If we are applying, instead of, here we are showing tensile load. Instead of tensile load, we can show here compressive load. So whatever if you apply compressive load, whatever the compression of part 1, same will be the what? Part 2. Okay? And
so in the diagram, sir, we can write that F1 and F2 for the
and sir,
loads.
see, F1 and F2, these are the internal forces.
Okay.
This F1, see, why we are not showing on this drawing? Because this F1 and F2, these are the what? Sir, how they are developing? They are developing internally. So that's why we are not showing on the drawing, sir.
Okay.
So, you got my point now, Sirji?
Yes, sir. Yes, sir.
So now, guys, you are getting my point. Try to understand the scenario. Any more doubt, guys, in this discussion?
Sir, can I little bit put my point of view, sir?
Yes, no problem, sir. You can put your point.
Like in equilibrium force, when at any point the number of forces are acting, then the forces acting towards that point or going out of that point, the sum will be 0. Sum of the forces will be 0. That's why they are in equilibrium. It will not move. They are balanced. So here we can consider F1 and F2 are the two equal and opposite forces. So when we say F1 minus F2, so they will be F1 is equal to F2.
No, sir. Don't say like that, sir. Don't say. Here it is not like that, sir. F1 minus F2, it is not like that. Here, whatever the force F we are doing, that force internally going into the what? Part 1 and part 2. That is what it means, sir. Don't say F1 minus F2, sir. How it is going, sir? How it is going? So, whatever the force F we are applying, some part of F is going into the part 1. Means, see, whatever force we are applying at this end, it is going to transfer to the other end. But while transferring, how it is transferring? Through the material. So, some force F will go into the part 1 and some force is going into the what, guys? Everyone? Part 2. That is what it means, sir. Now, guys, just try to think on that like that. Oh, F we are applying. Some part of F is taken by the part 1 and some part of the F is going to taken by the part 2. That is what a equilibrium situation. Means then in that case our F is balanced by the force in part 1 and force in part 2. That is what means, sir. So please everyone write down this discussion. Guys, don't miss this point. For equilibrium, this discussion is what? For equilibrium scenario, guys, don't be in hurry. Everyone, write down in cool way. So guys, everyone, so this is all about equilibrium. Now, the second point is what? For compatibility. Everyone, second point. Now, the second point is what, guys? Everyone, for compatibility. Guys, see, in mechanics there are a lot of things. I am telling you only 50% thing because that is what important for us exam point of view. Few things I am not telling you guys, because it is not necessary for us telling you that things exam point of view. But if you still need it, guys, meet me after exam. I will tell you good books of mechanics. So don't worry. So for compatibility, relation, no, not equilibrium means relation between forces. Compatibility means what? Compatible. Oh, two friends are two friends are compatible to each other. Husband, wife. When there will be no divorce, if they're husband and wife, they are compatible to each other. So that is meant by compatibility. Compatibility means what? Relation between change in length means what? Whatever the extension of the part 1,
That also is
same will be the extension of part 2. Whatever the compression of part 1, same will be the compression of part 2. That is meant by they are compatible to each other. That is what it means. So then what? Relation between change in what, guys, everyone? Relation between change in length. So what we can say? Change in length of the part 1 will be equal to what, guys, everyone? Change in length of what, guys? Part 2. Everyone. So what is the relation between change in length? Change in length of the part 1 is equal to what? Length of the part 2. And so what we have seen for a change in length, guys, everyone? What is the relation of change in length we have seen earlier, guys? For any type of load. Can you tell me relation of change in length? For any type of load, what is the relation of change in length we have seen?
F into L.
For any type of load, that is only F into L by E. It is only for a static load. For any type of load, what we have seen, guys, everyone?
Sigma L by
Sigma
L by E. Means sigma 1 into L1 by what, guys, everyone? E1. Change in length of the part 2 will be what, guys, everyone?
Sigma to L2.
L2 by what, guys, everyone?
E2.
A2. So please everyone start writing down this discussion of for compatibility.